All right, we're recording. Hi, everyone. Thank you for joining me again. We are at day 2 of the Forge Online Bootcamp, the April 2022 edition. And again, if there are, for those of you who are potentially joining us for the first time this week, my name is Petr Broz. I'm a Forge developer advocate, and I will be your host during today's webinar. Again, if there are any of you joining us for the first time, the online bootcamp is an event that we've been running for a couple of years now. It's basically a way for us to help you, to guide you through some of the tutorials that we have available online, in case for those customers who are maybe more, who prefer a more guided approach, not just follow a content on a website, but maybe watch others go through the tutorial and implement the steps described there. The online bootcamp is a 4-day event where every day we cover different tutorials, different types of applications that we build. Some of them we run in parallel for different programming languages, in this case .NET and Node.js, and we also have EMEA and Americas versions of this webinar. So when we wrap up our webinar about an hour later, the same one will start for the Americas audience. And the way it works is that every webinar is split into 4 sessions where roughly for an hour, we developer advocates live code through a piece of the tutorial, and then you follow our steps and you code with us. And then we take roughly a 30-minute break where you can catch up if you fall behind on some of the coding, or maybe if you ran into a problem, you can ask questions. We can help you debug them and work those out, or you can just grab a snack, get a coffee, or go for a quick walk. And all the sessions are recorded, and we will again share those after the online bootcamp event wraps up. The topic for today, for Tuesday, is the tutorial we call a Hubs browser. So this is another tutorial from the set of new, modernized, updated tutorials that we are deploying to the forge-tutorials.autodesk.io website that I will provide in the chat so that you can go to the same tutorial and follow along with me. All right, this is the one. Let me open the tutorial in my browser. And let me share the link with all of you in the chat. So Hubs browser is the tutorial that we'll be following today. It's kind of similar to the simple viewer that was covered on day 1, but in this case, we're going to be using something called a 3-legged authentication, meaning that we're now going to be building an application that will allow our users to log in with their own Autodesk credentials, and it'll allow them to browse their own content in other products based on the Autodesk Forge platform. There are some of these available today, like BIM 360, BIM 360 Docs. Some of you may already be using it, I'm guessing, or Autodesk Docs, or Autodesk Construction Cloud, or Fusion Teams, for example. Let me see if I can restart the animation here. This is what it's going to look like. So we'll have a login button where the user will be able to log in with their credentials. And then on the left side, we will present a tree view showing all their different design data in different products, again, such as Fusion Team or Autodesk Construction Cloud. And then after selecting a specific design and a specific version of that design, we will simply load it in the viewer that occupies the rest of the real estate. I think this is a good starting point for any other types of applications that you may want to build in the future, right? This is the basic stuff. Again, being able to browse the user's content and being able to display it, preview it in your web application, and then you can take it from there basically and start adding your value, right? Start modifying the user experience, adding customizations to the viewer, things like that. All right, that is the tutorial that we're going to be looking at today. And again, this webinar specifically is focused on Node.js. As for the agenda for today, we're starting with a quick intro and again, a setup step, similar to what we did on day one, where we're just going to make sure that we all are using the same Node.js version or like a recent enough Node.js version, and that we are using the same code editor that we have a Forge account created. Then we'll take a 30-minute break, and then session 2 will be about implementing a basic Express server, just like on day one again, and some authentication pieces. These are going to be different today because, again, we're working with three-legged authentication, so we're going to have to implement some cookie storage and be able to retrieve information from cookies, handle the three-legged authentication workflow, and things like that. Then in session 3, we're going to look at we call them hubs. So hubs are basically what we call the data in the different products built on top of the Autodesk Forge platform. So for example, BIM 360 Docs is one type of a hub. Autodesk Construction Cloud, another type of a hub. Fusion Team or A360 could be another type of hub that you can then drill into and list its projects, list the folders inside the project, list items inside folders, list versions of a specific item, and all that what you saw in the preview in that animation. That's what we're going to be implementing in session 3, the logic for actually browsing the user's data after they log in successfully. And then again, in session 4, the last session, we're going to tie everything together by implementing a simple user interface that you again saw in the animation, adding the viewer and basically making sure that whenever we select a specific document version in the sidebar, in the preview, that we load the corresponding design into the viewer. And that's going to be it. That's our schedule for today. All right, so let's move to session number 1. Similar to day 1, we want to make sure that you have a Forge account created and that you have a Forge application created. Now, what that means, if you go to the dev portal, again, for those of you who might be joining us for the first time, this is where you'll want to log in or create an account if you don't have one yet. If you don't have an account, here you should be presented with a different button saying create a free account. That would make sure that you have a trial subscription for Forge that comes with some preloaded currency, something we call cloud credits, that can then be used when building your Forge application that needs to, for example, consume certain Forge services. So if you don't have a Forge account, please make sure that you create one. And again, here, okay, so the name of a button is sign up to try Forge. So you can create a trial subscription for now that will be valid for 3 months. And during those 3 months, you will have 100 cloud credits available to use towards different Forge services. And when you're done with that, let's make sure that you create a Forge application, or we call them sometimes Forge app credentials. What that means is, in order to communicate with the Forge platform, you need to authenticate yourself in some way. You need to let us know who that application that's communicating with Forge is, right? And we do that through these Forge app credentials. Now, when you create your account on the dev portal on forge.autodesk.com, under your profile in the top right corner, you should see this My Apps link in the menu. And it'll take you to a list of applications because, of course, you can have many of these. Because these are basically silos where, of course, data owned by one Forge application will not be accessible by other Forge apps. So if you don't have one, feel free to create an app using this button in the top right corner. You can also reuse the app we created on day one if you want to do so. Just be careful that there are certain settings that we need to set to a specific value there. And I'll explain those just in a second. So in my case, let me just create a new app. I'm going to call it something like Forge Online Bootcamp, and maybe I'm just going to say day 2. I'm going to use the same content for the description. And now the important part is the callback URL. On day 1, we just set some arbitrary value to the callback URL, but today, since we're working with 3-legged authentication, now we need to be careful about the value we put here. Now, what should go in there into that field? It's basically the URL where your application's users will be redirected to after they log in successfully with their Autodesk credentials. Because the 3-legged workflow, the way it works is that you will have some sort of a login button on in your web application. The user will click that button and they'll get redirected to Autodesk website where they can log in. They can enter their actual Autodesk credentials. They click login. When Autodesk confirms that they are who they claim to be, the Autodesk servers will redirect the user back to your application to a specific address. That is the callback URL, right? So we need to be careful because this is the URL where our server app then needs to actually be prepared to listen for the user coming back to our website from Autodesk, right? Because we will, during that redirection, the redirection will bring some additional information, a temporary code that we will then, as part of the 3-legged workflow, exchange for an actual access token. Now, the value we should set there will depend on, first of all, where we deploy the application, where it's running, if it's on localhost or if it's deployed to Heroku or Azure or someplace else. And it also depends on, obviously, the actual path, the URL that we implement in our application. Now, I know that in this case, we're going to be running everything locally on localhost port 8080. So I'm going to start by entering HTTP localhost port 8080. And I believe, and we can come back here and change this if needed. I believe that the application that we're going to be building today is going to use a callback set to, is going to be waiting for a callback on this URL, API/auth/callback. So let's use that one for now. And here for website URL, we can enter anything that this doesn't really matter. And again, in terms of APIs that we want our application to have access to, unless you have some very specific reasons for not allowing the app access to some of the services in Forge, I think you can by default just leave everything enabled, checked, and create the app. All right. So my application is now ready, created, and now I have these 2 crucial values, the client ID and client secret. And again, as I was explaining during day 1, these are your application's sort of username and password. So you definitely don't want to share the secret, the client secret, with anyone. That's like the password for your app. And these are the credentials that your application will use when communicating with Forge so that we know who you are. All right, and I see there are a couple of messages or questions in the chat, so let me take a quick look. All right. Very good then. So we have, hopefully you'll be able to get your Forge account set up and get your Forge application ready. And again, if you want to reuse the one from day 1, that's totally fine. You can just come back to the app on the portal and use the edit button. And for now, just make sure that the callback URL is set to HTTP localhost 8080 API auth callback. And let me maybe just copy this into the chat as well, because I believe that this is the URL that our app will be expecting the callback on. All right, going back to our presentation, one thing that you may also want to do, and this is something that unfortunately cannot be done immediately. This is something that takes time, but it's certainly something I would recommend that you do if you have an existing BIM 360 project or an Autodesk Construction Cloud project or a Fusion Team project that you're working with. For Fusion Team, I believe it's actually okay. For Fusion Team, your Forge application can access the content in Fusion Team automatically. But other apps, such as ACC or BIM 360, they actually require you to sort of whitelist a specific Forge application before they allow the app to access its users' data, right? So this is an added security measure introduced by the individual Forge-based products like Autodesk BIM 360 or Autodesk Construction Cloud, where even if you ask your user in your Forge application to log in with their credentials, the app by default will not be able to see the user's content in Autodesk Construction Cloud or BIM 360. We first have to ask an admin of BIM 360 account or an ACC account. We need to ask them to whitelist our specific application's client ID, right? So then the admin can whitelist this client ID, and then our application will actually be able to see the user's data in Autodesk Construction Cloud or BIM 360. So the process for this is explained in the tutorials as well. Let me follow that link and include it in the chat. This is the way it works, right? So if you are, or if you know an account administrator for Autodesk Construction Cloud or for BIM 360, you will be able to go to the account admin interface and add something called custom integration, right? So custom integration is basically one of the records in the whitelist where you say, yes, I do allow this Forge application with this particular client ID to access the user data. So this is how you would proceed. This is where you would paste the client ID of your app to basically whitelist it and allow that app to access the data of the Autodesk Construction Cloud users. So this is just something so you know. So for now, we'll be accessing other data, other designs in other hubs. But if you want to integrate your app with Autodesk Construction Cloud or BIM 360, this is the process that you would need to take. And again, it's not immediate. Unfortunately, this may take a while because even adding custom integrations into something like BIM 360 requires an approval or requires your BIM 360 account to be switched into a developer account. All right, back to our presentation and now the development environment. So again, in this webinar, we're going to be using Node.js, and we don't have a strict requirement for the version, but we do recommend that you use the LTS, the long-term support version at least. Now, the way you'll find out what version you're running, if you already have Node installed, would be in terminal or in command prompt. If you're on Windows, to run node-v. So you will see that in my case, I'm running Node.js version 17.5. And if I go to the website, nodejs.org, you'll see that the long-term support version is 16.14. So let's make sure that we have at least version 16 installed, because again, in these new tutorials, we may be using new features of Node.js that are available in newer versions of the runtime. All right, and for editor, again, as I was explaining during day one, you are free to use really any code editor you want, because especially with in the Node.js world, we may be running the app from a command line from a terminal. But if you, but we would again strongly recommend that you use the Visual Studio Code. That's the free lightweight version of Visual Studio. It's cross-platform, so you can run it in Mac OS, on Windows, on Linux. It's really powerful. It's really fast. I really like it. I think it's great especially for web server and web development. It's really great. And we also have this nice Forge extension that we developed for VS Code that I was showing on day one that you might find helpful as well. And during the tutorial, again, if you want to use Visual Studio proper or WebStorm or Notepad, that's totally up to you. It's just that during the tutorial, we'll be adding some convenience functions for Visual Studio Code so that you can nicely, easily run and debug the Node.js application from VS Code, but you're free to use any editor and just run the app from a terminal or command prompt if you want. You'll just need to make sure that you set some environment variables properly. That's really going to be the only difference. So, but if you're comfortable with doing that, comfortable with running stuff from command line, feel free to use any other editor of your choice. All right. Now there's a quick question. Let me maybe answer it now. Where do you add the app on ACC project admin? That would be so you need to be not a project admin, but an account admin. So that's basically, there is a construction cloud account or BIM 360 account that can have multiple projects in it. And in order to be able to add custom integration, in other words, in order to be able to whitelist a specific Forge app, you need to be an account admin. So let's say if I'm in BIM 360, then I need to go to the account admin section. And if I'm working with Autodesk Construction Cloud, I'll need to find the account administration interface, account admin. And then again, from there, you get to the same interface as in BIM 360, where you add a custom integration. And again, I believe that at least in BIM 360, the menu for adding custom integrations appears after you turn that account into a developer account. All right, so I have my Visual Studio in Visual Studio Code running here, ready to be used, and I have Node version 17.5. And again, you can just, if you don't have Node.js installed, you can just grab it from the nodejs.org. Just download the LTS version installer, and that will make the Node executable and the NPM, that's the Node Package Manager utility. It'll make both of these available on your system. And also, what I was saying on day one, I think it's kind of common to work with terminal or command prompt when working with Node.js. That's how server development in this ecosystem typically works, I believe. And if you're running on Windows and maybe you are not so sure about command prompt, what I would also recommend is installing Git for Windows. Git for Windows is basically a small convenience layer on top of the standard Git, the source code management system, the popular code versioning system. And this little layer on top basically adds some utilities for Windows specifically, including Git bash. So this bundle basically installs Git as well as a bash terminal on your Windows system. So then you can follow the exact same steps that I'm taking here on my macOS system, because I'm using a standard terminal with bash here as well. So then, that would be it would be the same process to, let's say, set environment variables using the export or other simple things that we may be using in this tutorial. Although we will try and use Visual Studio Code for most of the work so that we don't spend as much time in the terminal. All right. That was our demo. And that's it for session number 1. So now, again, this was pretty quick, so I can give you back a little bit more of your time before we meet again in roughly an hour. So what I'd like you to do is double check that make sure you have a Forge account and that you have created a Forge application with some client ID and client secrets, and make sure that you set the callback URL to the URL that we specified. That was the localhost 8080/API/auth/callback. Because and again, later I'll explain that part in more detail, but basically it's really up to you what kind of callback URL you specify, but you need to make sure that you are consistent both in the developer portal where you set up your application and in your code, where you implement the logic for the three-legged workflow. You can call it, the callback can be, localhost 8080/foo/bar, and it's totally fine, but you need to make sure that you use the same URL on the dev portal and in your application, because if these URLs don't match, the user will actually get an error when they will try and hit the login button to get redirected to the Autodesk servers. They will actually see an error saying, oh, the callback URL or the redirect URL does not match. And this is a common problem that people run into. So again, just, that's something to really keep in mind, that URL, the callback URL, needs to be the exact same in our code and in the dev portal. So we'll make sure that this is the case in session 2 when we start implementing the authentication logic. Alrighty. So that was session 1. So I'm gonna pause the recording, pause the screen sharing. I'll leave this slide on, and I'll be around in case there are any other questions or comments. So please let me know, drop me a note in the chat or in the Q&A. I'll try and answer these as soon as I can, so that if you are blocked by something, I want to make sure that you are unblocked as soon as possible, and you can continue working with us in session 2. All right, so thank you for joining me, and I'll see you roughly in an hour. That will be at 9:30 GMT time or UTC time. All right, I'll see you later. All right, awesome. Thank you. Welcome back to session number 2 of day 2 of our online bootcamp. In this session, we're going to start implementing our server side. We're going to put together a simple server application using Node.js and the Express.js, the popular web application framework. And we're going to start implementing some of the pieces of logic that will be needed for the authentication, for things like initiating the three-legged authentication workflow that we already discussed, where we're going to redirect our user to Autodesk website where they can log in and explicitly approve our application's access to their data, basically. And then they're going to be redirected back to a specific URL, that's the callback URL, that we need to be ready for on our server side, because that callback will include a temporary code that we can then exchange for the actual access code, which is something that we will then be using to communicate with Forge to get the list of all the hubs and folders, projects and folders and documents that this particular user has access to. Alrighty. Just a quick reminder, the standard two-legged authentication, this is something that was used on day 1, is the type of workflow where it's only our application, our Forge app, and the Forge platform establishing the trust between them, where the way it works is just our Forge application server side simply makes a request to Forge, to the authentication service in Forge, where that request will include the client ID and the client secret, right? Those are the credentials of our application. And then the Forge authentication service will respond with a temporary access token that can be used for 1 hour, typically, and that has certain types of privileges. What those privileges are is something we also control by defining the so-called scopes when making that request to the authentication service. So we can basically ask the service to generate a token for us based on our client ID and client secret that will be able to access data in buckets, maybe write new files to buckets, maybe read hubs and projects, or maybe do anything else really. And then that token is generated for us. Again, it has a limited time to live. And we can then use that token in all of our communication with Forge. Whenever we make other HTTP requests or SDK calls to different Forge services, we can keep reusing that token until it expires. Then we need to refresh it. That's the standard two-legged authentication. However, today, for our app, we're going to be using the three-legged authentication, which I mentioned a couple of times already. This is the workflow where the end user is also involved. So it's not just our application and Forge establishing the trust between them, but it's also the workflow includes an end user who needs to provide their explicit approval so that our app can access the user's content in other Forge applications, such as Fusion Teams, Autodesk Construction Cloud, or BIM 360 Docs. This is the process, this is the way it works. So first of all, as I mentioned, we will need to redirect our user to Autodesk servers so that the user can actually attempt to log in with their Autodesk credentials. Then after logging in successfully, the user will need to approve our app's access. And that's going to be based on the scopes, right? So if we ask for data read and I don't know, what could be others like creating files, right? When the user is presented with a page where he needs to click that explicit approval button, he'll basically be presented with a user interface saying something like, this Forge application is asking you for permission to do this, this, and this, right? That information is going to be based on the scopes that we actually ask for from our Forge app. And when the approval is provided, Autodesk server will redirect the user back to us with this temporary auth code, and we capture the code and exchange it for an actual access token, again, by communicating with the Forge authentication service. And that's it. And now, of course, one more bit of complexity that we have compared to the app we were building on day one is that this token, obviously, it's going to be different for every end user, right? So we cannot just keep a single cached token on the server side and reuse it for whoever talks to our application. No, we will need to actually use something like cookies to store the individual tokens for the specific users that this token was generated for, right? So that when they visit our web application again next week, we can get that specific access token that was created when these users were redirected to Autodesk and provided the approval to our application. Alrighty, and we're moving to the first part of our Hubs browser tutorial on the Forge tutorials website. And what we're going to do is we're going to initialize a new Node.js project and install the dependency. So again, that's going to be the Express web application framework, and also a node module dependency that will help us with setting and retrieving the cookies from the Express application. And of course, we're going to install the Node.js SDKs for Forge so that we don't have to build all the individual requests to the different Forge services by hand. We'll just basically be making method calls on certain API classes, class instances, and these will under the hood build the HTTP requests for us, including all the requirements, the headers and the proper payload formatting, things like that. And we're going to put together a quick config JavaScript file where we're going to collect all the inputs to our application. Typically, these inputs are coming from environment variables, so that's where we're going to take them from, and we'll make sure that all these inputs are basically collected in one place. That's going to be the config.js file. And then we can reuse these inputs and grab them in different parts of our server-side code from this config.js file. And for those of you using Visual Studio Code, we're going to create a launch configuration so that we can then easily run and debug our new Node.js application from Visual Studio Code. And finally, we're going to put together an initial server.js file, which is going to be the entry point to our application, where we're going to define the middleware and the different endpoints that our server will be able to handle and respond to. In the second part of this, in this session, we're going to implement the authentication logic. So again, that's going to be the piece of code where we're going to need to use to, again, be able to redirect a user to the Autodesk servers where they can log in and provide the approval for our app to access their data, to exchange the temporary code when they're redirected back to us for an access token, for storing the access token in cookies, and for retrieving the tokens from the cookies. So that's what we're going to build as part of this session. All righty, let's look at the application setup. So I'm going to start from my command line again. Let me create a new folder here. Browser. All right, make this a little bit bigger. So we're going to initialize our Node.js project the common way, just by calling npm init. That's the command you would use to just scaffold a new Node.js project that will just create a new package JSON file, which is sort of like the metadata for your project, defining the dependencies that your Node.js project requires and different scripts that can be used to run that project in different ways. So let's do that now. Now, I'm going to type in, I'm going to add -y at the end to make sure that the init command is not asking me for any details, and it just sets everything to the default values. So if I do that, it just created a package JSON file for me with the name guessed from the folder name and some default values for things like version or license or scripts. Again, it's npm init or npm init -y from the command line or from command prompt on Windows. And again, you should have the Node executable and the npm executable available on both systems when you install the Node.js runtime. If you don't, let me know in the chat or in the Q&A. All right, so we have our project initiated, initialized. Now, again, it's just a package JSON file with nothing interesting in there. Now, what we're going to do is we're going to use another npm command, this time the command called install, to add some dependencies. As you can see here, we're going to call npm install --save. This basically means when these dependencies are installed, also capture these dependencies and their versions in the package JSON file, so that later on when somebody else maybe wants to set up this source code on their own system, they can just type npm install, and that command will go through all the dependencies in the package JSON file and install the right versions for them. So we're installing Express. That's one of the most popular web application frameworks for Node.js that will help us, but they'll make it a little bit easier for us to build different server endpoints and add middleware layers that process all incoming requests. We will also add this other one that I was mentioning, cookie-session. This is a middleware for Express. That means, again, a piece of logic that will process every incoming request, and that will also process every outgoing response with certain type of functionality. In this case, cookie session, it'll basically look for a specific header in every incoming request, and if it finds whatever it's looking for, some special name of the header, it'll retrieve all cookies from there for us, so that then later on, in our Node.js code, we don't have to worry about going through request headers. We will have the cookie values available directly on the request object that we are going to be working with in our Node.js code. And similarly, for outgoing responses, whenever we set any kind of cookies on the outgoing response, this cookie session middleware will make sure to grab these values and encrypt them and store them in a special header in the outgoing response. And finally, the last piece is the Forge-APIs. This is the official Forge SDK for Node.js language. So that's what we're going to use to communicate with the Forge authentication service, with the Forge data management service, and potentially with others. So that, again, we don't have to build HTTP requests from scratch. That's what the SDK will do for us. All right, let's install the dependencies. This may take a little bit of time, and we're good. Now, if I try and look at the package JSON file one more time, you'll see that now it actually contains this dependencies property that the install command added for us because of the --save flag. So now, if we were to share the source code with somebody else, or publish it to GitHub and somebody else wanted to clone that repo and set it up locally, they can simply type npm install without any other parameters. And the install command will basically look at the package JSON file and see, okay, there are 3 dependencies with a specific version that was installed when we originally, when we added these dependencies. So that other person, whoever wants to reuse our code, this will make sure that they are using the exact same versions of dependencies or the compatible versions of dependencies that we used initially. All right, so we have our dependencies installed. Now we're going to create 3 more folders, just like we did on day 1, where we're going to keep the client-side assets like the HTML, CSS, JavaScript, and then we're going to create another folder called services, where we're going to define all the server-side logic that will be reused in different parts of the server. And finally, the routes folder is where we're going to implement the individual endpoint handlers, right? So the code that should be executed when somebody makes a request to our server with a specific URL. Let me, well, you know what? Let me just open these in Visual Studio Code, say open folder, and I'm going to navigate to the temporary folder that I have set up for today. Yes, I trust the authors of this code. So what you should see when you open that new folder that we've prepared for our project today, you should really just see a node modules folder. This was created for us automatically when we ran the npm install command, because this folder contains all these dependencies that we installed and their nested dependencies in a flat list as well. So you can see there's a lot of stuff here. This is the Express dependency that we installed, and that project itself may depend on other things such as debug and cookie and async kit. And so this is basically a flattened list of our dependencies and all their nested dependencies. And a package log JSON is something that was created also by the npm install command that will capture the actual versions that we're using in this project. So this is automatically generated. You don't have to worry about it at all. And so this is what the folder structure should look like. And as we mentioned earlier, we want to create 3 more folders in our project folder. One of them will be the www root. This is where we're going to define all the client-side JavaScript, CSS, HTML. Another folder called services. That's going to be all the logic used on the server side. And finally, routes. This is where we're going to implement the logic for the individual server endpoints that our server will be able to respond to. All righty. Next step, as we mentioned, let's collect the inputs to our application from the environment variables. This is how, again, it's quite common to pass information to Node.js apps through environment variables. So we're going to do the same thing here. So let's create a new file in our project folder called config.js. Let me copy and paste the content in here. And let's quickly go over what this is doing. So we're using the built-in process object in Node.js, which is really the information about the process in which our Node.js script is running. And process.env is a dictionary of all the environment variables that are available to our Node.js app. So we're using this destructuring syntax with the curly braces on the left side of the equal sign. So we're basically cherry picking these couple of environment variables from the process.env dictionary, right? So we're expecting the process that where our Node.js code is running to contain a couple of environment variables with these exact names: forge underscore client ID, all uppercase, forge client secret, forge callback URL, and server session secret. I'm going to explain in a second what these are for. And maybe we can also check if the environment variables contain a port value that with a number that we should be running on, that our server app should be listening on. And if it's not available here, you can see we just default to number 8080. And we also define a couple of additional configuration options that are not retrieved from the environment, but these are just some options that we will need in different parts of our application. So we just centralize them and put all the configuration stuff here into a config.js file. And finally, we export all these values out of this module so that we can bring them into other JavaScript files in our Node.js project. Oh, and also a quick note, some of these we know some of the environment variables we know will be required. So if they are not really provided, that's this if condition, right? If any of these forge client ID or client secret or callback URL or session secret, if these are missing, any of these, we issue a warning and we exit the process immediately, right? So we don't even start the server. So again, if you try, run the application and you see this error or warning missing some of the environment variables, that's an indication that, okay, maybe I'm not providing all the environment variables that my Node.js app expects. All right, now we're also gonna add a launch configuration. So again, this is just for those of you who are using Visual Studio Code. A launch configuration is basically a way to tell VS Code how it should run and debug your application. So you can have multiple launch configurations, maybe to run and debug your app in different ways. And so let's do one thing. First of all, let's go back to our package.json file, because here in the launch configuration, we will basically be trying to run an npm script called start. And that script is not yet available in our Node.js project because we haven't specified a start script in our package.json file. So let's do that now. In the package.json, find the scripts object. This is where you can define different commands that you can run using npm, using the npm utility from the command line, for example. Here, what I'm going to do is I'm going to create a script called start. And what that will do under the hood, it'll just call node server.js. So it'll basically call the Node.js executable with server.js script that we will eventually create. And we can run this whole thing just by typing npm start from the command line, basically. So it's like a convenient tool to save you some typing and not, so that you don't have to worry about, okay, which is the entry point file that I should be running in this Node.js application. Now, instead, you can just type npm start, and the package.json file npm will find out that, okay, the user is asking me to start this, node with this server.js parameter. All right, and so now let's create a VS Code launch configuration. Launch configurations are stored, or any VS Code content configuration settings are stored in a .vs code folder, and specifically the launch configurations are in a JSON file called launch.json under that .vs code folder. You can either create it by hand, or you can, when you switch to this run and debug side panel, you can see that you actually get a little link to create a launch JSON file for you. If you do that, it'll ask you what sort of runtime you want to create the launch configuration for. If you're trying to run maybe a .NET Core project, or maybe you're running a Blazor WebAssembly project. In our case, it's Node.js, so we're just going to select Node.js, and that will create this VS Code folder, or .vs code folder, and the launch JSON file. So here, this is where you could start defining, different launch configurations, give them different names, and have them execute different type of, have them execute your application in different kinds of way. But for now, let me just copy the content of the launch JSON file from the tutorial website and replace everything inside the original file with the new content. So basically what we're saying here is there's going to be a single launch configuration for our project. It will run npm start when we want to debug the app. We gave the configuration the name launch server. And now the interesting part here is you can specify additional options for your launch configuration, and you actually get a nice IntelliSense here. So if I if I were to create these double quotes, I can immediately see all the different parameters that how I can configure my launch configuration. I can specify the current working directory. I can do all sorts of things. But the one important piece for us here is a property called env file. With this, we're basically telling VS Code, hey, when I want you to start and debug this application, look for a specific file and grab everything you find in it and set it up as environment variables for the debugged process for my program, right? So that I can then read the information from the environment variables. You can place that file whatever you want, but in my case, when you do it by default, I think if I were to create an env file, I think VS Code just automatically pre-populates the path to this placeholder in a workspace folder. That's the actual folder of our project, and .env. So let's follow this suggestion, and we can just create a new file called .env in the root folder of our project. And here, the syntax is super simple. It's just key equals value pairs on separate lines that will then be read as key value and passed as environment variables to the debugged process. So let's define those values here, the environment variables that we're going to need. Let me copy them from the website. So if you remember from the config JSON file, there's 4 environment variables that we definitely need, otherwise our application won't start. It's the forge client ID and client secret. That's obvious, right? Callback URL. Now, again, this is the important part, right? This is the URL where we want Autodesk to redirect the users to if they log in successfully and if they approve our application to access their data, right? So this has to match exactly what we've configured on, on the Forge developer portal under My Apps, right? So be careful about that. And finally, server session secret. I'm going to explain what that means later. This is basically, as we're using the cookie session dependency, right, to save and load cookies from requests and responses, we're gonna encrypt them. So this environment variable is simply used as like, okay, to grab some sort of a string, some sort of phrase that can be provided to our application by whoever is running it to encrypt and decrypt cookies when processing different HTTP requests and responses. That's it. So we could hard code some secrets into the code, but that's not really good practice, right? That's why we are expecting this one more environment variable where we expect whoever's trying to run our app to provide some sort of encryption phrase. It could be any arbitrary string, really. So let's define these 4 required environment variables in our .env file. So some client ID. For that, I'm going to have to go back to my application that I created today. So client ID I can copy over. You don't have to use the double quotes. I think those are only needed if you wanted to use some special characters. Client secret, again, this is the one you do not want to share because that's a sensitive information. I'm going to now have to share it with you because I'm sharing my screen, but that's okay because at the end of the day, I'm just going to use the regenerate button to create a new client secret for this application so that nobody can watch my video on YouTube next week and steal the credentials and use them for their own work. Now, Forge callback URL, this is where we come back to the callback, right? So let's just make sure you can see what I'm setting. The URL I'm setting to the environment variable called Forge callback URL is HTTP localhost port 8080/API/auth/callback. So let's just make sure that this is the same that we have actually configured for our application. And it is. So that's good. All right, and server session secret. Again, this is any arbitrary string that I want to use to encrypt and decrypt cookies in our server app. So I can just provide, I don't know, an arbitrary string value here. All right, that's it. And the final piece now is the server JS, the entry point to our application. that for now isn't doing really a lot. As you can see, what we do is for now we just create a new instance of the Express object, right? That's really the web application instance. And then we call a couple of these use methods on the app object. These are basically building the middleware stack. That is something that we also covered on day one. But again, for those of you who are joining us for the first time today, the Express framework has this concept of middlewares, which is, you can think of it as you are stacking pieces of logic, like different functions on top of each other. And then whenever the server receives any kind of request, the request goes through all these functions in the stack until it reaches your own code that can react to the request in any way, right? And the different functions, the different middlewares, they can choose to completely ignore the request and let it pass through, or they can choose to maybe look for certain information. And if they find that information, they can maybe add some additional properties to the request object that is flowing down through the stack. And some middlewares can even decide to not even let the request continue through the stack, but maybe answer them immediately, right? So let's explore some of the examples here. First of all, we're adding a middleware called this Express static. That's basically a middleware that will check for every incoming request. It'll check if by any chance that request is looking for a static file in a specific folder, in our case, in the www root folder. So if the incoming request is, for example, coming to http localhost 8080/images/logo.png, this middleware will try and see, well, is there perhaps an images folder in www root, and does it perhaps contain a file called logo.png? And if it does, it will respond to that request immediately, so that request will not even reach anything else below it. That's a simple middleware for serving static files in some pre-configured folder, in this case, in the www root folder. And the other one, here you can see we're already using the cookie session middleware. So we're adding a middleware layer that will look for a specific header on every incoming request. It can be some arbitrary header name that the layer itself defines. And if it finds that header information, it will basically parse the content into cookies, and it'll make the cookies available on the request object itself, so that if we are answering any requests below this, we don't have to worry about parsing the cookies. The cookies will already be parsed and ready to be used by our own logic, right? And similarly, when we respond to a request, when that response hits this middleware when leaving our server, this middleware will also make sure to check if there are any cookies on the response object, and it'll encrypt them using some sort of secret phrase. That's the environment variable that we're expecting, right? And it'll save the encrypted cookies back in the header that will go out with the response. So there's this nice idea where, again, a lot of these requests and responses will be processed automatically for us, so that our own Node.js logic can just worry about, reading a value from cookie, maybe setting a value to a cookie, and everything else will be handled for us by the stack, by the middleware stack. And finally, when the stack is defined, we just start the application on the pre-configured port number and report the success to the console. All right, so let me grab this code, go back to Visual Studio Code, and create a new file in the root folder called server.js with this new code. That's it. Oh, and by the way, the middleware for the cookies, we also we can add some additional parameters. In this case, we're setting the cookies to expire after 24 hours. All right, we have our package JSON updated so that when we type npm start from the command line, it will run Node with our server.js file. We can try that from the command line, and that we know that won't work, because if I want to start my application using Node server.js, I'm not providing the environment variables, right? That makes sense because we haven't provided any environment variables here in the terminal. So the Node.js project process does not have the information that it needs. But if instead we run our application from VS Code, right? So now if I switch over to the run and debug section, I will already see a launch configuration here called launch server. Remember, that's the one that we've defined in the JSON. What it'll do is it'll run npm start, just like I did in the terminal, but it will also read the .env file in our project folder and parse all the key values as environment variables and add them to our process. So let's give that a try. And boom, good. So our server is now ready. It's running on port 8080. It's not doing anything yet, but it's already running and expecting our requests, right? So we can give it a try. We can go to HTTP localhost, and we should see a cannot get / That basically means that this incoming request has gone through all the middlewares in the stack, and none of the middlewares, none of the code was able to actually respond to this request. None of the middlewares understood what this request is and how it should be answered. So then Express just responds with a default message saying cannot get something, right? So meaning I don't understand what this endpoint is doing. I see if I try and open, go to /foo/bar, that's the same thing. The Express server does not know what I'm trying to, what I'm asking for, what the browser is asking for. All right. So our app is running. That's good. And we can move to the next section, which is the authentication. All right. So what we're going to do is we're going to create a couple of helper files under the services folder with code that we can then use in other parts of the server. So first of all, let's create a new subfolder under services called Forge. This is just in case that maybe in future you would want to have. This is just to structure the code a bit more, right? I mean, we could just push everything into a single folder. That would also work, but might be a little bit harder to navigate. And in here, create a file called auth.js. So under services, you should have a new folder called Forge, and under the Forge folder, you should have a file called auth.js. This is where we're going to define a couple of these helper functions. So let me copy them and again explain what they're doing. So what we're doing here, we're bringing in some of the configuration values from our config file, right, that we have in the root of the project folder, and we're bringing in a couple of classes from the Forge Node.js SDK, specifically this auth client three-legged and users profile API. So we're going to be using these classes to work with the three-legged authentication workflow and to do things like request information about the specific user who has just signed in and for whom we have just generated an access token. And we'll use that to maybe show the user's name in the top right corner. And then we have a couple of helpers, helper functions. This one, for example, get authorization URL is something that will generate the URL that we need to redirect the user to initiate the three-legged authentication workflow, right? So by calling this method, we will get a URL somewhere on the Autodesk servers that we need to redirect the user to. Auth callback middleware, right? So this is now, again, going back to the idea of middlewares in the Express framework, which is, again, a piece of function, a piece of code that will sit somewhere on a stack on top of the server application, and it will process every incoming request, and it also has the chance of reacting or modifying every outgoing response, right? So every middleware, expects these three parameters: the request, incoming request, outgoing response, and next, in case it just wants to pass the request to the next middleware in the stack. Right? So maybe if you want to respond, you can immediately respond. But if your middleware only wants to run some custom code, but it wants to let the request continue through the stack, we just call next at the end, as we do here. So what are we doing? Well, we know that this middleware, well, we call it auth callback middleware. So this code we're going to use later when the user is redirected back to our application from the Autodesk servers, right? So what we're going to do is we're going to try and pick the temporary code from the URL. It's going to be, the code will be passed in as a query parameter called code. So that's why by typing req.query.code, that's basically our way of retrieving the actual value of the code parameter from the URL query. And we're going to use the get token method of the Forge authentication client to exchange the temporary code for an actual access token, right? So here we call it internal credentials, but it's basically it. That's the access token we get from Forge in exchange for the temporary code. And then we also call a refresh token, because this access token that we retrieve for the user will also have a limited time to live, right? It'll only be valid for 60 minutes. But then when those 60 minutes expire, we don't want to ask the user again to log in and to provide their approval, right? That would be a little bit annoying. So instead, we can get a refresh token as well that we can store somewhere, let's say in our case in cookies. And later, let's say in 60 minutes, when the user wants to access our page again, we don't have to ask the user to log in again. We can use the refresh token to get another access token. And that's basically what we're doing here. Generating an access token with the internal scopes, meaning that that's going to be a token that is powerful, right? So this is something that we're only going to use internally, because the internal scopes, well, in this case, they only have the power to read data, but even that might be something that you only want to do on the server side, that you don't want to expose these privileges to the token that's going to be used by the viewer eventually on the client side. So we're generating our access token with the internal scopes, the data read, but then we're also calling refresh token on the public. We have a separate authentication client that will generate a token for public use, right? So this public auth client will only generate tokens that have a single scope, single capability, and that's viewables colon read, which means they will only be able to load translated files into the viewer, and that's it. All right, so we define these two tokens, our internal token with the internal data reading capability, and the public token with viewable loading capability. And we store these in this rec.session, right? This is the cookie session, right? So whatever kind of property we store on this rec.session object, when the response goes back through the cookie session middleware, the middleware will make sure that all these properties and their values are encrypted and stored in a cookie. And when the user makes another request, maybe a week later, right, the cookie session middleware will find the cookie information there. It will decrypt it, and it will read all these properties there and make them available as standard JavaScript properties on this JavaScript object called session. So we just decided to name these properties public underscore token, internal underscore token, right? So we store the data there, and we also store the refresh token, and we store information about when these tokens expire, so that next time the user makes a request to our server, we can actually check if the tokens are still valid or if they need to be refreshed. And with that, that's actually what this next helper function is doing. And that's another type of middleware, but here we call it auth refresh middleware. This is one that will actually look for every incoming request and see, and it'll grab information from this session object, which again, this object will be created by the cookie session middleware, and it'll try and check if there's a refresh token available there. If not, it will immediately respond with 401, which means unauthorized. So this means that if wherever we place this middleware, any incoming request will need to have this session object and some refresh token available Otherwise, this middleware will immediately stop all the other execution and it will immediately respond with 401 access is not authorized. And otherwise, if there is a refresh token, that's good. We check if the expiration, if the token information in the cookies is expired. And if it is, we just call refresh token again, right? To generate a new internal access token and new public access token. Again, we use the same refresh token method from the Forge SDK. And we store the new values again on the request session object so that when we respond, right, the cookie session middleware will make sure to grab all these properties, encrypt them and their values, and store them in a cookie so that this cookie will be stored in the user's browser. And again, when they come back to us the next day or the next week, we will have these values available on the rec object again. All right, that's it. And then we also store the token itself in a specific object that we just decided to call internal OAuth token and public OAuth token. This is something that we're then going to be using in the rest of our code in the different endpoint handlers, where we actually need to retrieve the token for communicating with Forge services. So this is just, again, a convenience code where we just grab the information that's already in the session object and we just make it available directly on the request object under some, recognizable property name. And then we pass the executions to the next middleware in the stack. All right, that's for handling the callback and auto refreshing tokens from cookies. And finally, one more helper function, get user profile. This is using the user profile API class. This is what we're going to use to, given a token that was already generated by a certain three-legged authentication workflow, we're going to make a request to the authentication service to retrieve information about the user for which the token was generated, right? So that will include information like the user's name, potentially email, and some avatar image URL and some things like that. So we're going to use this information to again display either the user's image or the name somewhere in the UI of our web application. And that's it. And we expose these helper methods and middlewares from this Auth.js file so that we can reuse it in other places. All right. And we can now build our first router. So again, routers are another concept of Express. And they are basically objects that can be mounted to a specific URL prefix, for example, /API/auth. And then whatever paths or whatever endpoints are handled in the router are actually then handling the complete URL by taking the path prefix like /API/auth, let's say, and then taking the endpoint in the router, let's say /callback. That code will then be executed for any request coming to /API/auth/callback. Let me show you an example. Let's grab this code for our first auth router. Go back to Visual Studio Code, and under the routes folder, create a file called auth.js. This is what it looks like. We create a new router, and we define a couple of endpoints that this router will be able to handle and answer, right? So the router will be able to handle any GET requests to /login, any GET requests to /logout, GET requests to /callback, etc. What it does is not really doing a lot, right? So you can see here, in case of the GET request to something /login, the router will simply redirect us to some other address, and that is the authorization URL, right? That's our helper function that will generate the Autodesk address that the user will be redirected to log in and approve our app's access to their data. Now for logout, what we do is, you can notice here, we just set the session object on the request to null. This is basically our way of clearing the cookies, right? Because then when this response goes back to the client, the cookie session middleware will notice, oh, the session object is now null. That means that this server application wants me to clear the cookies. So it will basically remove the cookies that it used previously. Now, callback, this is the important part, right? When this router is eventually mounted to some URL path, which in our case will be /API/auth, this code will be executed whenever somebody makes a request to /API/auth/callback. And that is, if you remember, the callback URL, right? This is the address. This is the URL that the user will be redirected to after logging in. And what happens here is, instead of immediately defining the code that should be executed when somebody makes this call to our server, we include this middleware, right? That's the auth callback middleware. So again, if we go back to it, what we do is we look at the incoming requests, and we expect that there's going to be a query parameter in the URL called code. That's the temporary code from the three-legged authentication workflow. And we're going to exchange it for an actual access token, right? This is the code where we retrieve the internal token with the internal privileges, scopes. And then we also generate a public token that has the only capability viewables read, meaning it'll be able to load files into the viewer. And that's the token that we're going to share with the viewer in the final session. All right. And then for the token, there's going to be another endpoint. It's going to be /API/auth/token. It's a mouthful, but this is basically the URL that the viewer will call to get a new access token that the viewer can then use to load models from Forge. And this is including the other middleware. This is the refresh middleware, right? So whenever the viewer will ask this /API/token/auth/token URL to retrieve new public token, we will make sure to run this code through the refresh middleware first to make sure that if the token is expired, it'll be refreshed. And finally, this code will be executed whenever for any incoming request to /API/auth/profile, right? So this is something that we're going to call from the client to retrieve the details about the user who has just signed in. So we call the helper function called getUserProfile, and we simply return a JSON with a single property called name, where we just concatenate the first name and last name from the response we got from Forge to this specific user. That's it. All right, and final piece, the router is not yet used anywhere. We need to mount it to our application. And that is done, we will do that in the server JS file by adding this line app use. Let's see. This is the process of the mounting that I mentioned earlier, right? So any kind of endpoint in the router is basically appended to the mounting path, right? So let's say, again, this code in the router will be executed for any request coming to /API/auth/profile. This is the idea where you can then grab this router and you could potentially mount it to multiple different paths, and that way you would have single piece of logic that is handling multiple different endpoints that just maybe work in a similar way. All right, that is it, I believe. So now we can try and run our application. Let's see, run our app. And it's ready, listening on port 8080. And now let's try something. If we just try and go to localhost 8080, we will still get the cannot get / because obviously we still haven't implemented anything that the server could respond to when somebody asks for just localhost 8080, right? We don't have any handling logic for this URL. But we should now already have logic for handling this login. So before I execute this, let me go back to the code and see what this should do, right? So in our router, this is the code that should be executed when I go to /API/auth/login. We should be redirected to some custom Autodesk URL where we can log in and approve this Forge application's access to our data. So let's see if that works. We can maybe put a breakpoint here. Let me try and make this request. All right, let's see, let's try step into the function. Can we step inside? No, okay, we're already outside. We can let the app continue and see now, okay, we've been redirected to auth.autodesk.com, something, right? Now, I had already logged in previously, so now Autodesk is not asking me to log in again because Autodesk already has some cookies in my browser saying that, okay, I had logged in previously, but now it's asking me, hey, there is this application called Forge Online Bootcamp April 2022 day 2 is requesting permission for the following information: reading data. And again, this is because in our app, we've configured the internal scopes to only ask the user for data read, right? If I added more scopes here, that online form would be including more information, that like more permissions that this app is requesting. And I'm going to say, yes, allow. And maybe again, we can try and put a breakpoint in the router, because this is, or maybe in the middleware, actually, that might be a better place. Callback middleware. Let's do it this way. I'm going to say, yes, allow. And now I'm going to be redirected back to our callback URL. And I've here intercepted that request, right? So the incoming request, let's see if I can check what it looked like. The incoming request looked like this, right? It included, Autodesk included some temporary code in the URL. And here on line 12, I immediately exchanged that temporary code for an actual access code, access token. That's the one here. And you can see that I immediately received not just the access token from the Forge authentication service, but I also got the information about how long, how many seconds this token is valid for, and also a refresh token that can later be used to refresh this access token. And here our public credentials are not yet defined, but here by calling refresh token on the other authentication client with the public scopes, that's just the one for loading viewables into the viewer, we will generate the public access token as well. So this is a different one, right? So we now have two objects, two different access tokens, one for internal use, one for public use. And now what we're going to do is we're simply going to store these tokens and the refresh token in this req.session object, which is later going to be stored in our cookies, and we can actually check that. All right, done. So now we've been redirected back to localhost 8080, nothing, right? And again, we get the cannot get / because we haven't implemented the index page yet. But now what you can try is you can go to the applications tab. If you're using Chrome, I mean, other modern browsers like Firefox, Safari, or Edge have their DevTools as well, but the naming might be a little bit different. But in Chrome, you can just go to the application tab in the DevTools. And by the way, you can get to the tools by going to these 3 dots, more tools and developer tools. That's this interface that I see here. And you can take a look at the cookies stored for this page. And now I'm surprised that I don't see them here. Ah, there they are. All right. So you can see Google Chrome here lets us see what types of cookies were stored in our application by different, in our browser by different domains, right? So here for localhost 8080, this particular domain or the server running on this domain has stored a couple of things. couple of cookies in our browser, in our Chrome, right? And they're actually here. So now I'm surprised. I'm seeing a couple of tokens separate, but these are, I believe, from a different project when I was running, I think, the .NET version of our app earlier, which just stores the cookies unencrypted. So these are actually not related. We can delete these. The cookies that are related to our application are these ones, the session and the session.sig, right? This is a long encrypted message that's encrypted using the secret phrase that we provided to our application as the environment variable, if you remember. That basically just I believe just like a signature for that encryption. Right, so this is how the cookie session middleware is storing the 4 properties that we've defined on our request object, how it's storing them in the browser cookies, so that later on when I come back to, let's see if I can, here, I can put a breakpoint in our refresh middleware, so that later, if I come back to this website, maybe I want to make a request to the API auth profile, right? If you remember, this is the URL that we're going to use to request the name of the currently logged in user. That request will go through the stack and it'll eventually hit our auth refresh middleware. And this is where we just basically try and see, is there a cookie session, right? Object, the session object, and does it contain refresh token? If not, it would return 401. But this time, the cookies are already there. So the server application now knows which user it's dealing with. Now it checks whether the tokens in the cookies need to be refreshed. They don't. That's good. So we just set up some additional helper properties on the request object before it hits our code in the router where we ask for the profile, right? So now we're in our custom code, right? And now we can actually immediately use req.internal OAuth token, because we know that this property on the request object was created by the auth refresh middleware. So we can use this data to retrieve information about myself in this case, right? So I see the username, first name, the last name, some maybe email or image, profile images, right? And we just use it to build a JSON with the full name and send it back to the client. So that's it for session 2. Now we have our authentication logic working. And in session 3, we will start implementing the server-side logic for browsing the user's content in Forge using the data management API and going through hubs, projects, folders, items, versions, etc. All right, so hopefully you've been able to follow along. If you got stuck on anything, let me know. I'm going to pause the recording and the sharing again for roughly 30 minutes. This one actually went almost exactly for an hour. So we now take a 30-minute break, and I'll see you back here at 11 a.m. GMT time, where we're going to move over to the data management functionality. All right, I'll see you in a bit. All right, we're recording. Welcome back, everyone. Welcome back to session 3. Now, in this step, we're gonna start implementing the server-side logic for the data browsing, basically, right? So once we have an access token from a specific user, we can use that token to communicate with the Forge data management service to start navigating their content in different products based on the Forge platform. Now, on day 1, we were using the OSS, right? The Object Storage Service, which is something you can see on the diagram here at the very bottom. That's the multi multi-tier, multi-level architecture of the Forge data management service. Today, we're going to start using the additional layers of the architecture. So we're no longer just going to be working with flat lists of objects in a bucket, but we're going to start iterating or enumerating the different hubs, projects, folders, items, versions, and things like that, which ultimately then in the end, these specific item versions, document versions, they still point to an object sitting somewhere in a bucket. All right. So this is just a single step of our tutorial, a Hubs browser tutorial. We're going to implement another set of helper functions under the services subfolder that will then be used by a server, by a router, express router, that will answer the different endpoints asking for information about hubs, projects, folders, etc. All right. Let's go back to our tutorial and we can jump to the data browsing step. So again, let's start with the helper functions, right? So for those, we will create another file under services/folder, Forge folder. And the file is going to be called hubs.js. Let me copy the content, bring it to VS Code. So again, that's going to be under the services folder, Forge subfolder. We're going to create a file called hubs.js and paste the content in here. And let's see what this is doing. So we basically here just provide a couple of functions to, first of all, get a list of hubs, then get a list of projects in a specific hub. And just to remind everyone, hub is that silo of data that typically represents a specific product or project built with the Autodesk Forge platform. So a hub can be Autodesk Construction Cloud, or another hub can be BIM 360 Docs or Fusion Teams. And then we also provide a couple of helper functions to list the contents of a project, which could be folders or contents of a specific folder. Here we just provide the same implementation with an optional parameter to the function where if this third folder ID parameter is not provided, we just list the top folders of a project. And if the folder ID is provided, we list the contents of that specific folder instead. And also a helper function for retrieving the versions of a specific item, right? So this is all the code that's going to be used to drill down in the tree, right? So to drill down from hubs, projects, folders, all the way down to items and versions. And for that, we're using different classes from the Forge SDKs. So we use this hubs API class and the get hubs method, which is again the same thing as making an HTTP request to the data management service asking for a list of hubs. And similarly, we're using the projects API class to get a list of projects in a specific hub. And under the hood, this is just a single HTTP request to the Forge data management API to the web service. And in all these, we're passing in all these methods, we're passing in the internal auth client. That's basically the client that we use to store the internal token with the data read capability, right? That's really the only purpose for this internal token at the moment. All right, and we export these helper functions from our Node.js file so that we can then bring this information into other parts of our source code. All right, now for the server endpoint, in the routes folder, we're going to create another router and define it in a file called hubs.js. So once again, let me copy the content of this route/hubs.js and bring it into VS Code. So under routes, I'm going to create a file called hubs.js and paste the content in here. And again, what we're doing here, this is going to be an express router that will handle a couple of different endpoints. And we will then mount the router to a specific path in our server application. In this case, it's going to be /API/models, I believe. Let me check. sorry, /API/hubs. So this is where we're going to eventually mount this router. So for example, whenever somebody makes a request to our server with the URL /API/hubs, this code is going to be executed, right? So in this case, oh, sorry, this one. So in this case, we're going to use our helper function to retrieve all the hubs available to the specific user based on their access token. And we're gonna return the hubs as a JSON. And similarly, when somebody makes a request to /API/hubs/ some specific hub ID/projects, we're going to use the helper function to retrieve all the projects within that specific hub and return them as JSON again. So super simple. And when somebody asks for content of a specific project, we use the helper function, passing in that optional folder ID, if you remember, right? So this is something we can then use to append something like folder ID equals something to ask for the contents of a specific folder in the project. Without this parameter, this URL will simply be responded to with the top folders in the project. And finally, when somebody makes a request to /API/hubs/ this whole thing, we're going to use the helper function to retrieve all the versions of that specific item, the specific item in a specific project. That's pretty much it, pretty straightforward, I believe. And this is something that we will then use on the client side to populate the interactive tree view component in the left sidebar. All right, that is for a router. Now, again, we must not forget to mount it to our server application. So if I go back to server.js, and here I'm basically adding this router as another middleware. So any requests starting with /API/hubs, something will be attempted to be answered by this router. And that's it really for the data management. So now let's see if we can explore to see how that works. So now, again, if I go to localhost, nothing's going to show up because we haven't implemented the index and endpoint yet. But now we should already be able to go to something like /API/hubs. This basically should return the list of hubs that I, the user who has currently logged in, right, that I have access to. We can try that by placing a breakpoint here. And when I make that request, yep, we've intercepted the call. So now we can call our getHubs helper function and see if we've received any hubs. And in this case, there's only one because I haven't really provisioned my my app's access to any specific Bit360 account or ACC account. So at this point, I only have access to a single hub, and you can and I can tell because it starts with a dot that this is going to be an A360 hub or an my data in A360 that I'm storing. And we're going to return the list of hubs in as a JSON. Right, so that's where you can see that here, right? So a single response from our JSON, from our API hubs endpoint, JSON with a single output, an A360 hub called Petr Broz in this case. So it's an A360 personal hub. You can see based on the schema here. So this is what we can eventually use to populate the tree at the top level, right? To say, okay, you have access to a single hub or maybe potentially, multiple hubs. And okay, now what we can try is we can grab the ID of that hub and we can try and append it to the URL, right? Because if you remember, the other type of endpoint that our server should be able to handle is this API hubs, some hub ID followed by /projects. So this should give us all projects available inside that hub. So let's give that a try. There we go. So how many are there? Okay, so it looks like in my A360 hub, there are 4 projects total. The last one is called demo project. You can find some additional information coming from the Forge data management service, right? This is for some other potentially useful linking to other types of data. And it looks like here it's actually already pointing you to a root folder for this project. But now we're using a different approach. We're basically using the Forge data management APIs to get all the top level folders in a given project. All right, so we have 4 projects here, and let's try drilling even deeper. If we append the project ID and then say contents, that should give us all the top folders available in that specific project. So let me copy the project ID and say contents. All right, and you can see that this returns a single thing, which is a folder. And this is the ID of that folder. So now what I can try and do is I can say, okay, now give me the contents, and then I'll pass in a folder underscore ID query parameter, which is something that we came up with for our code, right? This is a query parameter that our code expects that it can change the response based on this parameter, right? So we're saying we don't want to see the top level contents of the entire project. We want to see the contents of this specific folder. And when we do that, all right, you see that we've gotten now actually many different objects in response, and these are items. So this would be your individual designs, right? So in this case, Wally. Right, so this is again how we will populate the trait. And then for a given item ID, I can again drill one level deeper, provide the item ID and follow by /versions. This is getting a little bit contents, item ID, versions. And that should return a list of versions of this design that are available, in this case in A360. So there is just a single version that was created in March of 2021. So this would be ultimately the piece, the object that we would try and load into the viewer, right? Because you can actually see that this ID is already can already be turned into a URN, as we discussed on day 1 using a base 64 encoding. And this is going to be the URN that we're going to be sending to the viewer, asking it to load this specific this specific design for us. All right, so this was actually pretty quick. And that's the topic for session 3. It's really fast. So that gives us more time just in case there are any questions. And I see there's one thing in Q&A. there is a question saying, do we need to use ngrok to connect our local PC to cloud, I'm guessing? No, that is not needed. Ngrok is something that would be useful for that. For those of you who are not familiar, so no, you definitely don't need that today. Let me show you. Ngrok is one of the tunneling utilities that you can use to basically have a publicly visible URL that somebody can make requests to. And you can see those requests tunneled to your local machines, right? So for example, imagine that I'm developing my local application, right? My server application locally, and I would like someone to try and make a request to it. Today, when I'm developing the application locally, they cannot really do that because I'm running on localhost, right? So nobody else can just type HTTP localhost 8080 to reach my app. But sometimes even when you're developing things locally, sometimes you do want to have your locally running application available publicly. For example, this is important when you're working with something like webhooks. So webhooks are a pretty widespread concept in server development, that webhooks are something that you can use to get notified of certain events in different systems. And Forge actually provides webhooks as well. So in Forge, you can set up webhooks to have your server application get notified when something happens in the Forge ecosystem. So for example, when somebody uploads a file, or when somebody deletes a file, or when somebody starts a new conversion of a file for viewing, anything, right? Maybe you want to get notified when that happens, but you are developing your application locally. It's running on localhost, right? So if you could tell Forge, hey, when something happens, when somebody uploads a new file, make an HTTP request to localhost, that's not going to work, right? And that's where tools like ngrok are really useful, because with just a single line, command line in the terminal, you can open a tunnel. So ngrok can generate a publicly visible URL for you, and and tunnel the request coming to that public URL to your local host, right? And so then you can have Forge webhook make a request to some public URL, and you will actually, that request will actually reach your server running on localhost. So for those type of things, it is really useful to have something like ngrok tunnel requests to public URLs. But in this case, we don't really need that. And I don't see any other questions. So unless there is anything else you need help with, we can actually keep this session. Well, this was really short. So I can give you back more time. I'm guessing many of you, it might be around lunchtime for you, so feel free to grab some lunch. And I'll see you back here at 12:30 GMT or UTC time, when we will basically tie everything together with the UI and the viewer, where we're just going to show the tree view using these server endpoints that we have just implemented. And when the user selects a specific version of one of the items, we will just load it into the viewer. And I'll be monitoring the chat and the Q&A again. So if you have any questions or feedback or comments, or if you get stuck on anything, let me know. All right, and I'll see you later. Okay, we're recording. So once again, welcome back, everyone. Thank you for sticking with me. This is the final session of the day of our online bootcamp. And in this final session, as I already mentioned, we're gonna tie everything together, take all the logic that we implemented on the server side and bring it back to the client. We're gonna have a single page web application with a simple HTML, a little bit of CSS styling, and a little bit of JavaScript code that, first of all, populates this tree view, which is going to be a third-party JavaScript library that we're going to be using. And so we're going to be populating that library with that tree view with the content from our server side, right? That's going to be the hubs, projects, folders, items, versions. And the rest of the web application real estate, we're going to use a big canvas for the viewer to actually load and display the models that we select in the tree. All right, how are we going to do that? This is the final piece of the Hubs browser tutorial on the tutorial website. So again, we're going to add this time 3 JavaScript files with that encapsulate different parts of the logic on the client. So one of these viewer.js will be the logic related to Forge viewer and initializing the viewer and loading models into it. And Sidebar JS will be the file where we're going to implement the tree and the logic to populate that tree. We're going to be using a third-party library called Inspire Tree, and I'll show you how to bring that dependency into our web application. And finally, a main.js will be the main JavaScript file defining the actual logic of our application that's going to tie together everything from the login button and the sidebar and the viewer. And yeah, a little bit of HTML and styling, as I mentioned. And that will be our application for today. So let's get right onto it. Viewer and UI. So let's start by, and all these assets will live inside the www root folder, right? That's where the static file middleware is gonna be looking for static files that somebody can be asking for with requests to our server. So let me, so we'd start with the viewer.js file. Let me copy the content and bring it to Visual Studio. So under www root, we create a file called viewer.js and bring in the code from it, code from the tutorial website. And again, this is just 3 functions. 2 of them we actually export from this file because this JavaScript will be treated as an ECMAScript 6 or ES6 module. So that's where we're going to see this export import syntax being used. This is a nice clean way of combining multiple JavaScript files on the client side together without having to include all of them in the HTML or without having to bundle them using something like Webpack or Rollup. So there are, in fact, like we are exporting 2 functions from this JavaScript module, init viewer and load model. Init viewer will be used to simply initialize forge viewer in a specific HTML div container. So this is the Autodesk.viewing is the namespace that's going to be available when we bring in the JavaScript library for forge viewer. So calling this global function Autodesk.viewing.initializer will make sure that we actually fetch all the different dependencies that the viewer itself may depend on, right? So the viewer may require a couple of additional JavaScript files. It may require some static assets for graphics, for icons, or for environment maps, things like that. So this is all going to get downloaded when we call this Autodesk Viewing Initializer method. And then in the callback, because this is an asynchronous process, when that is ready, inside the callback, the second parameter to the initializer, we actually create a new instance of the viewer in the provided HTML element container. And we start the viewer for now without any model. And we set something. So this will initialize and open, start an empty viewer, and it'll make it available for us later so that we can start loading models into that viewer object or into that viewer, viewer canvas. And the second helper method is the load model. This is where we're going to pass in viewer and a URN, a model that we want to load into the viewer. URN, also something we discussed on day 1. This is the base 64 encoded ID of the object that we want to load into the viewer. And the base 64 encoding is used to make sure that the object IDs that we're using in the URLs when communicating with Forge, for example, with the model derivative service, that the IDs that we're putting there are URL safe, because sometimes the IDs of different objects may contain characters that are not safe to be used in URLs because that could be question marks, slashes, things like that. That could confuse whoever is then trying to parse the URL. That's why we are base 64 encoding the IDs when communicating with services such as Forge model derivative service. And these base 64 encoded IDs we then call URNs. And that's actually even the format, the type of ID that the viewer expects. So as you can see here in the load model function, we will be calling this Autodesk.viewing.document.load. This is a static method on the document class, document.load. That will basically retrieve the manifest or like the metadata for a specific design that has been uploaded to Forge and converted by the Forge model derivative service. This manifest includes information about what types of outputs were generated from this design file, right? So, for example, if we're talking about a Revit design, Forge typically extracts several different 2D sheets and several different 3D views from a single Revit file. So this manifest or document that we're loading using this document.load static method will contain all the information about these outputs and some other data that might be useful in future as well. And what we do is we just provide two callback handlers, one function to be called in case of success when the document is loaded correctly, and one in case of failure. And if the document is loaded correctly, what we do is we just use this little doc.getRoot.getDefaultGeometry. This is a function that will basically go through this manifest, this document JSON, representing all the outputs from our design file, and it'll find the default output that was generated. And that default output, we then load into the viewer by calling viewer.loadDocumentNode. This is a standard function again, that you'll find in the API reference for the viewer on the developer portal in the documentation section. That's our two functions here. The get access token is just basically a way for the viewer to be able to ask someone, in this case, our server, for a refreshed access token, because the viewer itself will also need an access token if it wants to load some 3D geometry or 2D drawings from the model derivative service, right? It cannot just ask Forge to download any kind of data without any form of authorization. So that's why typically the way this works is that when we want to initialize the viewer, we pass in a function called getAccessToken, or it can be named whatever we want, but it's basically some kind of a function that the viewer can call whenever it wants to start loading models from Forge, right? And whenever an access token maybe expires, so it needs to get a new one. So we are giving it a function that it can call whenever it sees fit. And the function that the viewer will call, it just needs to accept a callback that should be called with the access token and the number of seconds during which the token will remain valid. So that's what we do here, right? In our get access token function, we make a request to our own server. If you remember, /API/auth/token, /API/auth/token is the request that we handle with this code, right? We use our middleware to just extract the information about the internal and public tokens from cookies. And then we simply respond with a JSON with including the public access token that we extracted in our middleware from the cookies. That's it. So we're basically just this endpoint, we just respond with a JSON with the public access token from the cookies. All right. That is for the viewer.js function. The next one is the Sidebar Js file that will control the behavior of the tree view in on the left side of the web page. Let me copy the content of this script again, bring it to VS Code, and let's go over what it's doing. So under the www root folder, create a file called sidebar.js and copy the content there. So again, this provides a couple of functions, helper functions. Some of these are exported. In this case, just a single one. And what they're doing is, let's start with the last one. Any tree, right? This is going to be our helper function that we will call later to initialize the tree view component and make sure that that component is populated with the right data, with the right nodes. As you can see here, we are using a third-party dependency, a library called Inspire Tree. This is a open source tree view library in vanilla JavaScript that supports features such as dynamic children, which is something that we need this is a component where a list of children for a specific node of the tree can only be requested later, only at the moment when we actually expand that node in the tree, which makes sense in our case, right? Because we don't want to download all the folders, all the projects, folders, items, versions at the same time. We only want to fetch them when they're actually needed. In other words, when somebody tries to expand that folder or project or item in our tree on the client side. All right, so we're using an inspired tree. Again, we assume that the inspired tree class is already available in the global scope, which means that we will need to make sure before this code is called that the actual dependency, the JavaScript code of the inspired tree library is pulled into our application as well. And the way it works, this is you can find this in the documentation of the inspired tree. When you instantiate the tree, you can provide a data property, which is a function that an asynchronous function or a function that can return promises, where that for a given node, it can return the children of that node. Right, so basically that's what we do here. We check if the node parameter to our function is defined. And if not, we call a helper function called getHubs. And what getHubs is doing is it's calling the API hubs endpoint on our server side. And if you remember, that is the one endpoint that returns a list of hubs like ACC accounts and BIM360 accounts and Fusion team accounts where our logged in user might have some designs available. Otherwise, let me check here. And then we also create a tree node for every hub returned from our server side. And we use this convention where we give an ID to each node that in this case, it looks like it's basically a hub pipe followed by the ID of the hub. This is just, again, our internal way of how we're going to differentiate between different types of nodes in the tree, right? So create tree node. Here you can see what it's doing is just creating a JavaScript object with properties ID, text, children, and potentially iTree with an icon. So we're basically saying create a new tree object where the ID is going to be hub pipe followed by some ID of the hub. And this is something that we're later going to use to find out what type of object, what type of node the user clicked on. All right, so we return a list of hub nodes for the tree. And then if the node that we receive in the data function is actually defined, we check the ID, right? And we check the first part of the ID before the pipe. And if it starts with hub, we know that the user tried to expand a node in the tree that represents a hub. So in that case, we're going to try and retrieve all the projects within that hub, right? So tokens 1 is going to be the actual hub ID, right? Because we take the ID of the node, of the input node, we split it by the pipe. So the first token will be hub or project or anything else. And the second token will be the hub ID in this case. So we call our get projects helper function, which again simply calls our API hubs hub projects endpoint on our server side. And it then takes every single project returned from our server and it turns it into a tree node where the ID of each node will look like this, right? It'll start with project, pipe, then it'll be followed by the hub ID, pipe, and the project ID. So this is, again, just a way for us to encode the information into a specific tree node as to what hub and what project it belongs to. And then that's basically this case, right? So then when somebody clicks on that node representing a project, the tree, we're going to see that the first part of the ID before the pipe and says project. Yeah, that makes sense. In that case, we'll want to make sure to grab the contents, the top folders of that project, right? So again, as you may guess already, this is again calling, this helper function is calling the API hubs project ID contents, right? Retrieving the top folders of a project or retrieving the contents of a specific folder provided via the folder ID parameter, query parameter. And finally, when the user clicks on an actual item in the tree or a node that represents a data management service item, we try and ask for the list of all the versions of the document in Forge. And we map each version into a tree node, again, with this custom ID that encodes the version ID, which is that's actually the ID that we're gonna encode and turn into a URN that is then loaded in the viewer. So this is how we define how the tree should be populated. And later on, we also add an event handler for the tree component. That this is done through the .on method that you'll also find in the documentation of Inspire tree. And we say that basically whenever a node is clicked, any node in the tree, we check the ID of the node that was clicked, right? And if the ID starts with version pipe, we know that this is actually a version of an item, a version of a design, or a version of a document. And in that case, we want to react to that in a certain way, right? And the way to react to that node click is going to be controlled by whoever is initializing the tree, because that's going to be the second parameter, right? So this is going to be a function that we will call as soon as somebody clicks on a version node in the tree. And yeah, and then finally, we just create a new instance of Inspire tree DOM, which is basically a second component of the tree that will visualize the tree using DOM or using HTML, right? So we're basically saying, take the tree object that we have just created and display it in HTML in a specific HTML target that is at the first parameter provided to our init tree function. Right, and the final piece of JavaScript is the application logic. That's going to be in main.js. So let me copy the file, bring it back to VS Code to the www root folder. So I'm going to create a new file called main.js, paste the code here. And what we're doing is basically, well, there's going to be a login button in the HTML, right? That's going to be used to log in or log out of our application. So what we try and do is, first of all, we try and request the profile information of our logged in user. And we intentionally call it here, even though the user may not be logged in yet, because this is how we find out whether we should show a button that says log in or whether we should show a button that says log out, right? So we try and basically ask our server to get us the user information about the currently logged in user. If the response is okay, that means that the user is actually logged in. That means that our server was able to find some cookies with our user's access token. And in that case, we can actually parse the response from this server request, which is going to be a JSON. And we're going to use it to change the name of the button in the top right corner to log out, and we put the name of the user in parentheses. And when that button is clicked, we're going to call the API auth logout endpoint on our server. And if you remember, all that thing is doing, all the way this endpoint is handled by our server is simply clearing the cookies. That's it. So we initialize this log out button basically. And then we initialize the viewer, because now the user is logged in, so we're fine. We can actually go ahead and initialize the viewer. And then when we initialize the tree, the sidebar, and if you remember, the first parameter to our helper function is the HTML selector, basically telling us where in the HTML the tree should live. So we're basically telling it, okay, there's going to be an HTML element with the ID tree, and we want the tree to live there. And the second parameter to the init tree method or helper function is like what should happen when somebody selects a specific version node in the tree. And in that case, we will call load model, right, to load a specific URN into the viewer. And now this weird thing, you might be a bit surprised to see this. This is basically a way to base64 encode IDs in the viewer, in the browser, right? So the browser has a built-in function called B2A. That's why I'm saying, window.b2a, because this is a global function available in the global scope. And when I pass in any kind of string, this B2A function will base64 encode that input string, right? And what we do also at the end is we take any of the equal signs that may be on the end of the base64 string, because these are called, base64 has something called padding that we don't really need in this case. So we remove any equal signs from the base64 encoded ID. And that's our URN, right? So this is the second parameter to our load model function that will load this URN into the viewer. This all will happen if the user is already logged in, if our server was able to find some tokens in the cookies. If that's not the case, if the request to /API/auth/profile fails, that means that our user is not logged in yet. In that case, what we do is we change the text of the login button to login, and we change its on-click event handler to, instead of calling API auth logout, we are going to change the URL of our current browser tab to /API/auth/login. So again, if you remember, what that means is that once we click this login button, we will be redirected to /API/auth/login. And that endpoint, show you, will redirect us to the authorization address on the Autodesk servers. So effectively, clicking the login button will redirect us to Autodesk, where we can enter our credentials and explicitly approve the Forge app to access our data. And that's it, right? That's really it to set up the login button and the tree in the viewer. That's all there is to it. Okay, let's go back to the tutorial, and we can just add the HTML and a little bit of styling. So user interface, let me just copy the CSS file. This is going to be a file called main.css, also in the www folder. Let me create a file here called main.css and copy the content. So again, this is just some simple styling for the layout of the app. So we just have, we want the actual web page to cover the entire height of the viewport, of the browser. And we want to have 0 margin and paddings around. And then we just have the 3 main divs, right? The 3 main areas. We have the header, we have the little sidebar for the tree, and we have the main area for the viewer. So that's just these header, sidebar, and preview elements. We set their all their position to absolute, meaning that we will be controlling their position and size instead of leaving that to the browser layout engine, right? So we say the header is certain amount tall, and it covers the entire width of the top of the screen or of the top of the browser tab. And then it itself uses something called a flex display to lay out its content. So any items inside the header will be laid out using flex method. This is a modern layout technique where you can easily, we can use properties such as justify content or align items to control how the different children of that header element will be laid out in it. Then the sidebar is, we just specify here that it's glued to the left side, and it occupies 25% of the entire width of the browser page. And it's also offset by this 3 EM units from the top, because that's where the header is. And and the preview, basically that's where the viewer will live. This area occupies the rest of the page. And a few minor adjustments where everything inside the header HTML tag will have a bit of margin and hard-coded height. The login button, nothing special here. Oh, well, one thing we did add is, and this might be a bit strange, this is something called media query. In CSS, you can actually have custom styles being applied to your elements depending on something, whether you are when the user is viewing the page for printing, or for just viewing, or depending on, for example, the size, the width of the page where your HTML content is rendered. And here, what we do with this media query, we're basically saying if the width of the page where our HTML content sits is less than 768 pixels, then we want to change or override some of the proper CSS rules and properties, right? So originally, we were setting the sidebar and preview elements to cover 25% and 75% of the width, right? So that they would be sitting next to each other. But if the width of the page is really small, we actually switch to both of these occupying 100%, right? So they actually become, are no longer stacked horizontally, but they're now stacked vertically. One taking the sidebar, now taking the first 25%, the top 25% of the real estate, and the preview taking the remaining 75% of the real estate. And some icons. All right, that's our CSS. And finally, the markup, right? So our index HTML, let me copy it, bring it into VS Code. So under www roots, create a new file called index.html. And this is really it, right? So this is the 3 elements that we are styling, right? These 3 divs are basically covering or controlling the layout of the entire page. It's the header at the top, where we just show an image, title, and the button, login or logout button. Sidebar is where we host the tree view component, and preview is where the viewer will live. And then in the header, in the head, and at the bottom of the body, we are bringing in some of the external dependencies. So viewer3d.js coming from developer API Autodesk.com. This is the forge viewer dependency, this one and the CSS style here, right? So the viewer itself needs some CSS styling as well for its toolbar, for the panels and everything. So these 2 dependencies, the CSS file and the JavaScript file is something we need to bring into our application so that we can start using Forge Viewer APIs. The other dependency is the inspire tree, right? So that's these 2 scripts, because inspire tree itself, or actually these 3. Inspire tree depends on, I believe the documentation mentions that it requires this Lodash library as well. And we're using these 2 dependencies, right? Inspire tree itself that's the inspire tree class that we're using to define the tree and its behavior. And inspire tree DOM is the library that will allow us to render or display this tree in the DOM, in the HTML, basically, right? Because maybe somebody else might want a React tree, or somebody maybe wants to use display the tree in a different way, or using a different technology. So this one, inspire tree DOM, just visualizes the tree using standard HTML DOM elements. And the tree also comes with its CSS style, or some default theme. Yep, and that's it. And then we also, of course, we bring in our own CSS style, right? Where we define the CSS styling for the header, sidebar, and the preview elements. And we bring in our main.js file. Now, we don't have to explicitly add other scripts with the other sidebar and viewer JavaScript files, because here we specify this type to be module, meaning that's, again, going back to the ES6 modules, right? So this basically tells the viewer, hey, this JavaScript file is an ECMAScript 6 module, ES6 module. So be prepared. It may be importing other JavaScript files into it. And that's indeed what we're doing here at the top, right? So instead of us having to add these additional JavaScript files as script tags to our HTML, we can simply import any functions or code or classes from those using the standard ECMAScript import syntax, which I think is much nicer, because then the browser will make sure that these additional files are pulled from the server if you need them. Yep, and that is it. So let's, oh, and actually one more thing I noticed out. So we're expecting some logo PNG image to be available as a static file in our server, right? We don't have anything like that here. And I believe we are providing links to some logos on the tutorial page. So you can see here, I can grab a logo PNG and save it to our www root folder. Or I actually need to change the name to just logo.png. All right, this should be enough. So let's try and run our application. We can go to localhost. And now, if we don't provide any URL after this, the server will basically try and look for an index.html file, which we have now created. So we should already be presented with our app's user interface. And since I had already logged in previously when we were trying the different authentication endpoints, I should be logged in already. So I should see a logout button with my name, which indeed is the case, right? And I can double check that my cookies contain the session and session signature. Yeah, here, right? So this is the encrypted content of the cookie session middleware, where that is storing some of the properties that we added to the session object, REQ, that session object in the code. So that includes, so this encrypted string includes my public token, access token, internal access token, refresh token, and the expiration time or date. All right, so that's it. So let's see how this works, right? So right now, the tree didn't get any other information in the data method that we implemented. Let me just remind everyone what we're talking about, right? So that's this data function. Right now, it did this data function was called. It did not receive any input, so it just decided to show us a list of hubs, right? There is just one. Now, if I click on that hub, it'll try and look for a list of projects in that hub, right? That's basically this branch of the switch statement. So now we're listing all projects in my hub. I can maybe try and expand this project. I get the list of top level folders. There's just a single folder called demo project. And when I try and expand it, I get a list of items, all the items inside the folder, right? I can see there's already a couple of designs here that I can maybe try and take a look at. So let's see, there's a robot, inventor assembly. When I expand it, I get the list of versions, right? And it's really the bottommost part of the tree. So there's just a single version of this inventor assembly model that was created in 2018. So what I can try and do is click it. When I do that, that's basically where our main.js code sends the signal to the viewer saying, hey, load this version of this particular design, right? And I can now maybe try others. There's Wally. If I select that version of Wally, I get Wally here. And that's it, right? So this is our simple app where I can now, if I were involved in different BIM 360 projects or Autodesk Construction Cloud projects or Fusion Teams projects, and if the admins of those accounts provisioned access for my Forge application, I would actually, I would see multiple hubs here, right? BIM 360, ACC, and others, and I could see my content there as well. And then, yeah, and that's basically, again, this is I believe, a good starting point for you to start adding your own value, right? So you can now build this app where your users can log in and browse their content from, let's say, BIM 360. And after selecting a specific design from BIM 360, they can you can start implementing additional features, customizing the viewer. That's something that we're going to be looking at tomorrow, how you can basically take this app and start customizing the behavior of the viewer, because a lot of the functionality that is currently available here in the viewer through the UI, like checking the logical hierarchy of the design, right, and being able to navigate around, or exploring the properties of the individual design elements, and many other things. You can do all this stuff programmatically as well using the viewer APIs. So you can start building different extensions for the viewer where you can, for example, query information about all the different components of the elements of the design, and then maybe color code them based on certain criteria, or you can hide them, or you can bring additional geometry into the design to indicate something. You can overlay the design with annotations, or you can bring in like other external data sources. Let's say if you have like an ERP system, you could customize the viewer, adding a custom panel looking like this one, but instead of showing some metadata of the selected design coming from Forge, it could actually be showing your own data coming from an ERP system or any really kind of database, for example, that you might be using to store some custom information for the different design elements. So this is something that we're going to be looking at tomorrow. All right, and that concludes our tutorial for today. So do you have any questions? Are there any questions, problems, comments, feedback? Please let me know. And if not, that will actually be the conclusion where, so yeah, I'll stay around for 30 more minutes in case you need to catch up and maybe run into any problems, but that's basically it. And if you don't have any other questions, I would just wrap up today by saying, okay, there's two more trainings that we would like to see you join. Tomorrow, as I said, we're going to be looking at, there's going to be the dashboard tutorial that is not language specific. So this is for both groups who join, .NET or Node.js. So you can bring your own application from day one or from today to that session, and we're going to start customizing the viewer. And I'm going to be showing you how to query the metadata and customize the UI, customize the behavior of the viewer, and things like that. Then beyond this week, if you're now intrigued by the capabilities of the Forge platform and you would like to continue working on it, there are some channels you can reach us to get additional help and support. One of these would be Stack Overflow. We're trying to be very active there. So if you ask any questions on Stack Overflow and you use one of these tags, we will get notified, and myself or one of my colleagues will hop on that question and try and answer from Stack Overflow. That makes more sense for questions that are not, nothing confidential, something that you think that might be beneficial for other users in the community as well. But if you have a question that's maybe more specific to your use case, or that involves some confidential information, feel free to reach out to us through email or this form when you go to the developer portal. That's the forge.autodesk.com website. When you go to support, get help, there is a form that you can fill out, and it will basically go into our system as well and notify us that there is a question from a customer, and we can get back to you there as well. And what to expect at the end of this week, or again, like generally after this event. Again, as I was saying, we will be sending out a wrap-up email with links to the recordings of all the sessions that were recorded this week. We will most likely provide the slides as well, because that's something that people are asking for sometimes. And we'll send out a link to a survey that we would really like you to ask to fill out for us, because again, it's a great way for us to collect the feedback, obviously, and make sure that the format and structure of this event is works for everyone, as much as possible. It's really useful and helpful for the community. And also, a quick note: if you want to take your skills now, if you've just gotten started with Forge, but if you want to take these skills to the next level, we run other types of events, and we provide other types of resources, learning resources as well. We run Forge accelerators. That's sort of like a week-long hackathon where you can propose a prototype, something you would like to build with Forge. And then with that prototype, you can come and join us. For now, still virtually, but in future, hopefully we'll be able to go back to live events where we will invite you to one of our Autodesk offices around the globe. The event is free. So we basically sit down there with you in a conference room for the entire week, so that if you run into any issues or you need to ask a question, we are right there, right at that time. It's not, you don't have to send us an email or ask on Stack Overflow and wait for the response. And we also have lightning talks pre-recorded about different topics related to the Forge platform. And we also encourage you to check out our blog, because that's where we typically publish articles that focus on specific narrow use cases that our customers want to use. So again, like maybe somebody is interested in, I was mentioning on day one, bringing point clouds into Forge, right? So we have a couple of blog articles on that, or maybe somebody else is interested in building a Forge application that can be used in offline scenarios, or in scenarios where maybe the user might be temporarily disconnected from the internet, let's say on a construction site. So we have a blog article on that as well. And that's all typically covered in form of a blog post. So do check that out as well. And that's it from me. So thank you for joining me today. And I hope to see you all tomorrow as well, where I'm going to be doing the dashboard tutorial. Yes, thank you. It was great having you here. And so I'll stop the recording now, stop the sharing.